Okay, chapter 9.8. Um, the title of the chapter is called Using the Sum or Difference Formula. And then I looked over it, it just kind of difficult. So I was thinking just to break this chapter down to a couple parts. So today we're going to talk about 9.8a. So I'm just going to quickly ask you guys to do something really simple. Um, just to find the sum of two angles in standard precisions. So let's get started. So first of all, I really need you guys to understand that there are two special right triangles. Okay, so first one is a 45, 45, 90 triangle. Okay, and another one is 60, 30, 90. I should call it 30, 60, 90 triangle. Okay, and we all know that the ratio is going to be for the 40 or 45, 90, it's going to be 1, 1, rad 2 for the hypotenuse. For 30, 60, 90 is going to be a 1, rad 3. For hypotenuse is going to be 2. So these are the two special right triangles and the ratios of each side. Really good to know because the next thing I want to talk about is going to be something related to these two special triangles. Okay, so for this next one I want to talk about is the special triangles in the standard precisions. So when we're drawing the special triangles on the XY axis using the terminal side, initial side, all that stuff, basically all the ones that we're testing you in algebra 2 is it's all coming from these three right triangles. I mean, from these two right triangles, and then it gives you three right triangles measured as a reference angle. Okay, so now I want to talk about the first one. It's going to be a 30-degree. We're going to be focusing on just quadrant 1. So I'm going to give you a 30 degrees. Okay, so this is a 30-degree reference angle. Okay, and the next one I want to talk about is a 45, 45, 90. Okay, this is a 45-degree angle. And the last one I want to talk about is the 60-degree reference angle. Okay, I'm not drawing these accurately, but I want you guys to get the point. Okay, so when you guys draw the terminal side for the 30-degree right triangle, the terminal side, this is a 30-degree angle. This is a 45-degree angle. And this is a 60-degree. Okay, when I'm talking about this is basically coming from the initial side, 0. Okay, 45-degree and a 60. Okay, so the quadrant 1 is actually kind of simple and straightforward. Let's move on to quadrant 2. Hopefully this is just like a review for you guys. All right, so let's go ahead and then look at quadrant 2. Okay, so I'm gonna draw the 30-degree angle. Okay, a 30-degree angle is basically saying that coming from the initial side, okay, that's 150 degrees to get to a 30-degree right triangle in the quadrant 2. Okay, if you're going to have a 45, 45, 45, 45, 90, that's basically saying that it has to be a 135 degree. If it's a 60 degree, okay, this is basically a 120 degrees in the standard precision. Okay, this is all strictly in quadrant 2. Let's go ahead and look at quadrant 3. Okay, so quadrant 3, I'll start with the 30-degree angle. So 30 is a 30, 60, 90. Okay, this is basically, this is 180 and then 30 more. So this is 210 degrees. Okay, um, for the 45, 45, 90. Oops, this is 180 plus 145, so this is 225 degrees. Okay, if it's 60, 30, 90, that's gonna be, this is gonna be 60 plus 180, that's gonna be 240. Okay, this is strictly in quadrant 3. Now let's talk about quadrant 4. So if it's a 30-degree reference angle in quadrant 4, this is basically the terminal side is basically 330 degrees. If it's a 45-degree reference angle, so this is basically saying this is a 315 degrees. If it's a 60-30 right triangle, this is basically saying that reference angle is 300 degrees. Okay, I just want to touch base with all the special triangles, how they look like um, on the terminal side, what the degrees in the standard positions. Okay, so now here comes the key understanding of what we're doing in 9.8a. I'm kind of struggling at first to teach this lesson, and I finally came up with something after looking at all of my worksheets problems and all the questions on the textbook. So first of all, um, I just want you guys to tell me if I give you for example, number one, I give you guys sine 285 degrees. Okay, I want you guys to tell me what can I, which 2 degrees or which 2 angles can I sum to 285 degrees? Okay, so this is what I want you to think of. So you're gonna give me 2 different angle measures that sum to 285 degrees. Okay, so I need you guys to understand that since we're going to have the uh, the triangles in only 30, 45, and 60 degrees as our reference angle. Okay, we need to make sure that um, the first angle you're dealing with, we're going to call this angle A, and we call the second angle B. Okay, we want to make sure that these 2 angles are able to become uh, 30, 45, and 60 reference angle on either quadrant 1 all the way to quadrant 4. Okay, this is a little tricky, okay, but I came up with a really simple way to teach you guys. So this is how you do it. So regardless of how big the number is, whenever you guys see a 5 in a unit digit, okay, whatever the unit they gave you, I mean, whatever the degree they gave you, if it's a 5 in the unit digit, and guess what? All the problems that you're gonna get is got a 5 as your unit digit. The first angle, I'll call it angle A, you're going to use 45 degrees. Okay? Don't worry about 30 and 60. Use 45 degrees. Okay? And then 45 plus what angle measure is going to equal to 285? Well, you can just use 285 to subtract 45, and then you get 240. Okay, so it's a 45 degree and 240, 240 degrees. This is all I want you guys to do in 9.8a. Okay, just come up with the two angles that sum to the given angle. Let's do it again. Okay, look at this. The unit digit is a 5. So what you need to do is write cosine. Okay, now the 255 is going to be broken down into a 45 degree. Another one is going to be 210 degrees. That's all I need you guys to do. It's going to be easy 10 points. What about this one? 165, okay? So unit digit is a 5. So you're going to use cosine. The first one I told you, it's going to be 45 degrees. Okay? Every single time. The next one, 120 degrees. This time it's a tangent. We don't have to worry about whether it's a sine, cosine, or tangent, okay? So look at the unit digit as a 5. So the first one I want you to put is 45 degrees plus 60 degrees. 75. Unit digit is a 5. So tangent. 75 is a 45. Add to 30 degrees. Okay, tangent to 85. So that's tangent 45 degrees plus 204 degrees. Number 7, sine 195 is 45 degrees plus 150 degrees. Okay, that's it for chapter 9.8a. I just want to let you guys know that if you guys go back to the video and look at all 7 examples, and then if you look at all the examples that I told you guys to start with a 45 to plus another measure of the angle, or I should say another angle measure, look at that second angle measure, or we can call it angle B. All 7 examples of the angle B can be drawn a special right triangle on the in the standard position. Okay, all of them can. Okay, and that's going to lead us to learn about 9.8b, that we're actually going to be using that information to come up with 2 special right triangles, and then using the formula we're going to be using later. Okay, that's going to be in the next lesson. Okay, so this lesson, chapter 9.8a, easy stuff. Just work on it. Just good luck. Stay healthy and safe.